Alright, hello everybody, welcome to lesson 5 of Arduino Fundamentals. Today we're going to be working with loops and arrays. So loops and arrays are basically ways that we can contain multiple elements together and do sort of multiple things at once inside of code. And so I know that I'm saying a lot, but let's get into actually understanding how it works. So this course for IEEE U of T, we hope that you are a university student. And if you are, an easy way to understand an array is almost like a vector. And so, like you can imagine like a vector of elements is multiple elements. So if I have, let's say, vector v, then inside a vector v, I could have like the elements, like 1, 2, 3, 4, 5, as many dimensions as I need, and as many elements as I want. And I can access them, so let's say this is my vector v. If I say v sub 0, that would mean v sub 1, that would be the first element. If I do v sub 2, that'd be the second element, and so on and so forth. For those of you who don't remember what vectors are, or don't have a familiarity with the concept, arrays are basically a way that we can store multiple variables together. And so last lesson we went through structs, and in structs we sort of gift wrapped multiple variables together, so different types of variables. And so we could put in functions, integers, and everything. But if we have everything of one singular type, then what we can do is we can very simply condense that into our array object. And so let's work with arrays and loops for a very simple use case of initializing all these button pins. Our goal with this circuit that I already made over here is very simply to make a passcode. So we can imagine this first button to be 1, the second button to be 2, the third button to be 3, and the last button to be 4. And depending on my passcode, so let's say I do passcode 4, 4, 3, 2. If my passcode is the passcode that I want, then I will get into the system and this light will turn green. If it's not, then it'll stay red, or it'll turn red, which is pretty cool. So let's get right into the news. Okay, perfect. And so the way that we're going to do this is we're going to first initialize all of our pins. Now, one way that you've seen me do this is just to do const int, we'll call it bu1, since b1 is already a sort of constant in Arduino code, and we'll call it 2, and then we'll do like bu whatever, but that's just too much effort. So what we can do is we can do something, or we can make something called an array, which is like a group of elements together. And so to signify an array, just imagine like this vector syntax of using these square braces around your numbers. You can just add a square brace around your variable name. So say int button pins maybe, would probably be more useful. Add our square brace. And then now, just like we did with the structs, we can gift wrap different variables together using these curly braces. So we're going to gift wrap the variables of all the pins that we have. So we know that we have 2, 3, 4, 5 corresponding to, or well, I guess 5, 4, 3, 2 corresponding to the order of 1, 2, 3, 4. So 5, 4, 3, 2. Where 5 is the pin for button 1, and 4 is the pin for button 2, and so on and so forth. Now that we've put our button pins inside of this array over here, what we can do is we can actually make use of it. Now, if I want to access an element, let's say I want to get v sub 1 in this vector, well, that's going to get the first element. In programming, the first element isn't actually denoted with 1, it's denoted with 0. And so if I want to get the first element of button pins, I could do something like this. So button pins, and instead of doing sub 0 like this, what we'll do is we'll use square braces like this and access the 0th element, or the first element. So button pin 0, this will return 5. And something like button pins 3, because we are, again, so 0, 1, 2, 3, would return this 2 value over here. Now, be very careful. If you do something like this, button pins 5, what this will do is this will give you a memory error. Memory error! And you really don't want a memory error, because if you do, your Arduino will basically break down and the program will break, and it'll do something called seg fault, or segmentation fault, which basically means the data you're trying to access doesn't exist and it just breaks apart. So you really don't want to get a memory error like this. So what we're going to do is we're just going to sort of, well, normally the way we do it was do pin mode, and let's say I want to do the first one. Button pins 0, input pull up. If I'm doing the second one, pin mode, button pins 1, input pull up. And you'll notice that the code is actually repeated. And since we have repeated code, there's actually a way that we can shorthand it. Just like we used functions to shorthand some of our code before, we can shorthand our code where we have only really one thing changing, but the rest of the code is the same thing, and that one thing changing is a number. And the way that we can do that is we can do something called a loop, or a for loop. And so a for loop is very simply a way that we can condense this piece of code you'll see over here. So we have our initial code, right? So let's create our index. So index is basically going to be what element we're on. So the index will go from 0 to 3. So this is the initial code that we have to do first. And then we have our repeating code. So whatever code we want to repeat, n number, or like however many times. So let's say we have well, before we add the code, actually, I think we should do the conditional code. So only run the code after if this condition is true. So this condition, we're just going to sort of put it into our terms of like, well, if index is less, or yeah, while index is less than 4, right? Because we want to go from 0 to 3, so it has to be less than 4. So that's our condition. So it has to reach this condition for the code inside of the loop to work. And then what we're going to do is we're going to condense the code that we're actually going to do. So this is like the actual repeating code, right? And so in our repeating code, what we're going to do is we're going to do pin mode, button, pins, index. So we're going to access the indexed element of our array over here, which would be 0, either 0, it could be 1, it could be 2, it could be 3. And then we're going to set this to be input pull-up. And then we're going to do our after code. And the way our after code works is just basically after we've done this, then we're going to run our code, or we're going to run this code. And the code that we're going to be running is going to be, very simply, index plus plus, which is basically just increment by 1. So if we were to put this into a piece of code, the way that this would work is we'd have like, well, we'd have our int index equals 0 if index is less than 4, then we run our code inside of this braces, pin mode, button, pins, index, input pull-up. Let me remove the double brackets here. And then once that's done, we're going to do index plus plus. And we just want to do this again and again. Well, in C++, there's a way to do this again and again, and that's, like I said, the for loop. And so the way the for loop will work is we're basically going to do for, and then we'll make these brackets to add our parameters almost. And inside the parameters, the way it'll work is this is going to be our initial code. Then we add a semicolon. Then it's our condition. So this is our conditional code. And then it's our after code. And in the brackets here will go our repeating code. So let's try to do that for what we did over here. Well, that would look more like for, what's our initial? Int index equals 0. Then we add our semicolon. Condition, well, index has to be less than 4. And then after, well, we're going to do index plus plus after our code over here has run, which is going to be pin mode, button, pins, index, input, pull-up. Perfect. So now we've gotten sort of our for loop code running over here. And what I'm going to do is I'm going to put this inside of a big comment so you can actually we can refer back to this line of code that I've written without it actually compiling. And let me just remove this code that we wrote before. So we basically shortened our code to initialize all of these button pins without having to write all of this code for every single one of the 0, 1, 2, 3, 4. And using the array was helpful because we could access multiple elements together by just changing this index over here, or this integer index. It's kind of the usefulness of arrays and loops and how they come in together, especially in Arduino code, just to shorten your code, because now we only use 3 lines, basically 2 lines of actual code, to initialize all of these different pins. And we could do the same for the LEDs, but honestly, because it's just the same 2 lines of code, we could just do that manually. And so what we're going to do is we're going to make our constant red equals 12, and our green equals 13. So now we'll just initialize these like we normally do. So pin mode, green output, pin mode, red output. Alright, perfect. So we've set up all of our pin modes and everything, and before we get in too far, we're also going to be using the serial monitor. So I'll do serial.begin 9600. The 9600 I hope was explained in a previous lesson, but that's just the baud rate or the frequency that we're communicating to the computer with. Cool. All right. So now that we have this in, we need to start creating a way to check if these buttons have been pressed. So let's first create code to see which button has been pressed and to output that. Now, a very simple way to do this in terms of reading buttons is we could do if digital read, and then we're going to say our pin, so we'll say button pins 0 because we want to read the first one. And we're going to say equals low. Then let's say we want to do serial.println 1 to say that the first button has been pressed. Now, let's say we want to do this for every single button. Well, you'll see that we will actually get another piece of repeating code. So you'll see that the only thing really changing here is a number, again. And so we can use this for loop syntax of for, initial, condition, after, and then our repeating, to make a new for loop that'll read all of our buttons and see what's been pressed. So let's do that. Let's condense this code and let's make a shorthand for it and make our lives easier. So we'll do for, and we're going to do int index again, because you can reuse variable names inside of the context of this for loop. And then we're going to say index less than 4, because we have 4 buttons, and then index plus plus. So these are, again, all of our conditions to loop through all of our different buttons, but now we have a different piece of repeating code on the inside. We first have to check if digital read button pins index. Again, we're going to access the indexed element instead of the 0th because we're going to be looping through all of them. Equals low. So if it equals low, then what we want to do is we want to do serial.println, and instead of doing 1 over here, we know that it's just going to be index plus 1, because instead of working with a 0 base, we're going to be working with a 1 base. So we can just do index plus 1. Alright, cool. So we've condensed our code, sort of, this piece of code over here, into this for loop. And so now it'll run 4 times over without us actually having to write the code 4 times over, making our lives much easier. So let's see this in action. Let me put this in braces, and let's run our code. So you'll see the serial monitor on the bottom, and all of it compiling, and if I press this button, oh my god, that's so many 1s. I didn't press 1 that many times. And so what actually happened is, because the Arduino runs way faster than us as humans, it'll have multiple computer cycles done by the time we press that button. So that button will be held for so long because we're humans, and when we press a button it gets held for very long, that it's going to mark 1 multiple times. So what we'll do is we'll kind of slow down the Arduino, and to slow down the Arduino, what we're going to do is we're going to add a delay over here. So we're going to say delay 100. So we're just going to wait for 0.1 second per button press. Now, this comes with its own complications. You'll see, if I run the code, if I press the 1, you'll see that it presses 1, but I really have to press it like multiple times because sometimes the computer is just a little bit too slow. So you can change this number dependent on sort of how your simulator works or simulator accuracy. For me, I think 0.1 seconds might be a little bit too slow, but I'll change it as I go on. You really can just change this value to whatever works best for your simulator. It's just that I'm running on a really old MacBook, so I'm just I set the delay up a little bit higher. Just, you know, change it to whatever your simulator runs at. Okay, cool. So we can read our buttons, but how do we get the passcode functionality? Well, before we get the passcode functionality, let's actually make our passcode. Let's go back to the top of our code and let's make a little password. So I'll call this my password or my passcode. And let's say we go back to our original example of the passcode is 4432. So again, we can use this array syntax of like I'm making an array over here, and then we can give it our gift wrap present of like, oh, these are the different variables on the inside. Now, one thing you need to know about arrays in C++, especially because you might need to go into this for the practice problems, when you're initializing an array, you can have one variable length parameter. So one of these parameters, or one of your curly braces, can be empty. And so because we're doing one-dimensional arrays or like one-dimensional vectors, this can just be empty. So I can add as many elements inside of these curly braces as I want. And if I don't want to do that, what I can do is I can put a number inside of here saying that there will be only 4 elements like this and then I can only add 4 elements inside of these curly braces over here. Now, the reason why I would want to add a number like this over here is so that it takes less time to compile the code, because instead of guessing how many elements are inside of the curly braces, your compiler just knows, like, yeah, there are 4 elements, I already know that, moving on. And another reason is if I'm making 2-dimensional arrays. And so 2-dimensional arrays, the way that they work is, it's basically like an array inside of an array. So first you'll have your curly braces, your gift wrap, and then inside of your gift wrap you'll use another gift wrap to wrap in one array, and then you'll use another gift wrap, so you'll use a comma to separate the 2 gift wraps that you have, and then use another one like this. And so this is a 2D array, and so to access a 2D array, what you do is you do like passcode, and then first you do passcode sub 0, or passcode sub 1 would return the first gift wrap, and then passcode sub 2 would return the second gift wrap. And so let me just make these different. So this would return the one that ends with a 2, this would return the one that ends with a 1. And what I can do is, once I have passcode sub 2, then I could do this sub 4 to get the last element, which would return a 1. So what this would look like in C or C++ would be passcode, and then which array I'm working with. So I could be working with array 0, which would be the first one, or array 1, which is the second one. So we'll say 1. And then what element I'm working with inside of that array. So I could be working with the element 3. And this can go up all the way to n-dimensional arrays, which all of you mathematicians can have fun with. But for the sake of our very simple code over here, we only really need to be working with a 1-dimensional code, or 1-dimensional arrays. Speaking of which, you can actually nest loops inside of each other, which we will be doing. So you'll be putting loops inside of loops, which is pretty cool. And again, if you need to repeat a piece of code, again, you can totally do that. So you'll see that our function over here is actually called a loop, so void loop compared to void setup. And what void loop means is that it's basically looping your code infinitely. So it doesn't have an initial case, it doesn't have an ending case. The conditional case is just true. It'll just keep looping forever and ever and ever and ever and ever and ever and ever and ever. And so this type of sort of loop where it doesn't have an initial case or an after case is called a while loop. And so just like here where we had a for loop that has for, initial, conditional, after, and repeating, the way that a while loop will work is that it'll have for, and then it'll have the conditional, or it'll have while, it'll have the conditional, and then it'll have your repeating code over here. So if you need to do something initially, you can do the initial code on top over here, and you can do any code that's after your repeating code, right? Well, after you write the repeating code. So that's a while loop compared to a for loop. Now, either or are basically the same. It's whatever you're more comfortable with. I'm introducing for loops because it's easier to loop through numbers with for loops, like this. Whereas with while loops, you'd have to use more lines to sort of go through the numbers. So it's just easier to use a for loop to explain looping through numbers. But let's compare our passcode with our series of inputted numbers. Well, to do that, we first need to get an understanding of what numbers have we inputted in the past. So we need to kind of keep a log of what current numbers we have. So let's make a new array, int current, of size 4. Now, we don't know what this array is going to be filled with. That's why I'm saying instead of using curly braces to assign a value to it, we're just going to say, well, it'll have 4 elements for sure, but I don't know what those 4 elements are going to be. Cool. So now that we know that, what we're going to do is we're basically going to say, okay, in this loop over here, if digital read blah blah equals low, then instead of just printing out the index, I'm going to add another line of code inside of here, and I'm going to create a new variable for myself called current index. Current index. And we know that current index is going to be 0 to begin with. And what I'm going to say is, over here, current index, or well, current, and I'm going to access the current indexed element of current index. So what I'm doing is this array over here of 4 elements, which if it's easier for you, I could define like this, 0, 0, 0, 0. That's another way to envision it. They're both the same thing. Current index is going to access the first element, or well, whatever current index is, or the current indexed element of this array, current. And inside of it, I'm going to set this value to index plus 1. And so what this means, what this equal signs means is, we've always been accessing value of an element over here, but like I said, it's like a group of variables grouped together. So you can actually change the value by just changing it like you change a normal variable. You access the variable name, and then you just change it to some new value. And so what we're going to be doing over here is we're basically just going to be setting, okay, well, the current indexed element of current is index plus 1, but then it'll always just keep setting the first element because current index is always just 0. So we need to increase current index. So what I'll do is current index plus plus. Alright, very cool. But wait, that doesn't work. What if I enter in 5 numbers? Well then current index will turn into 4, and if I access the 4th element of a 4-element array, well I mean the 5th element I guess, because we're starting from 0. If I access the 5th element of a 4-element array, we're going to get a memory error, and we know those are horrible because it'll break our Arduino. Well, it won't actually break our Arduino, it'll just break your code, and it's going to be really annoying and it sucks. So we need to make sure that we never go over. And this is where we can get into a little bit of tricky math to make our lives easier. If you remember from one of the first lessons, we went over an operator called the modulus operator. And the way a modulus operator works is it's basically the remainder. So let's say I do something like 4 divided by 3. Well, 4 divided by 3 would be equal to 1.333, but in terms of integers, that'd be equal to 1. Well then, what happens to that remainder? Well, if I do 4 modulus 3, it'll return that remainder of 1. I guess 4 and 3 weren't a very good example, so maybe 5 would be easier. 5 divided by 3 would be 1.66666, or, well, in integer terms, it's just 1, and 5 modulus 3 would return 2, because the remainder between 5 divided by 3 is 2. And so, you might be asking yourself, how is the modulus operator even relevant here? Well, think of it this way. What if we have our current index value over here? And we know that whenever we add current index plus 1, well, let's say this goes over and it turns into this value 4, because we know that 4 is equal to the 5th element. Well, one way we can mitigate this is we could just do current index plus 1 modulus 4. And what this would do is, if it's equal to 4, it'll just reset back to 0, because 4 remainder 4 is just 0. 4 remainder 4 is just equal to 0. Or I guess I'll use R. 4 remainder 4 is just equal to 0. And so to that extent, 4 modulus 4 is just equal to 0. So we could use this math trick of like, hey, what if I just do current index plus 1 modulus 4 is a new value? Because then that'll mean that, like, well, okay, 3 remainder 4, if I do 3 divided by 4, that's just 3. And then 2 remainder 4, well, that's just 2. 1 remainder 4, that's just 1. And 0 remainder 4, well, that's just 0. So it'll cycle backwards back to 0 whenever we change our value. So we can use this shorthand to set up our current index so that it never goes over our desired value of 4. And the way that we could do that is we could do current index equals, so the new value of current index is current index plus 1 modulus 4, because we have 4 elements. So we move to the next element that's in our array, or we cycle back to the first one if we're at the end. Perfect, that's exactly what we want. And so now what we can do is we can make a new loop over here to compare our current value of what our current array is. So we'll do over here. So we'll do 4 int index equals 0. Or, well, yeah, I guess we could call this like index, because we were just indexing. Index less than 4. Index plus plus. What we're going to do is we're going to say, so this is again our loop to go through the numbers 0 to 4, not including 4, so I guess 0 to 3. And we're going to say if our passcode at index, so the indexed element, so if the first element is equal to the first element of our current array, equals our current array, then we know, or then I guess we can say, yeah, those two are the same. But we want to make sure they're all the same. So what we're going to say is we're first just going to set up a very simple flag in our code. We're going to say, we're going to make an int, and we're going to say, are they the same? And we're going to assume that they are the same. Assume they're the same. And if we have any reason to believe they're not the same, or passcode at the index element is not equal to current at the index element, we're going to say this is, are they the same, equals 0, which means they're not the same. And then what we can do all the way over here is we can just say if are they the same equals 1. So if they are the same, then we're going to do digital right green high. Else, otherwise, we're going to turn the red LED on. Digital right red high. Cool. So now if we run the code, we'll see that the red is high because our current passcode is literally 000. But let's enter in our intended passcode. So 4, 4, 4, 4, there we go, 3, 3, 2. And so now you'll see, now you'll see that the green LED and the red LED are on. So what we want to do is we want to make sure we turn the red LED off here. So we'll say digital right red low. So we turn the red LED off. And here what we'll do is we'll do digital right green low. Alright, perfect. So let's run our code again. And so you'll see it's red because, it's not on. And so let's sort of run through our code step by step. And so what happened when we turned the Arduino on is we used this loop to initialize all of the button pins to be pull-up inputs. And then we initialized the green and the red LED to be outputs. And then what we're doing here is we're going to make a loop. And so this is just constantly looping inside of the Arduino. And it's going to say, hey, cool, I'm going to loop through all the different button indexes. And if any of them are low, well, I'm going to print that out into the serial monitor. And then I'm going to set my current index to be that, whatever that element is. And then I'm going to say, okay, I'm going to move my current index to the next element, which is going to be either the next element that's after it or all the way back to the start using this modulus 4 hack that we have over here. So now, let's set our thing up to be an incorrect code. So now I entered in 4. So now current 0 is 4. And we're at our next current element, which is 1. And we're going to press 3. Now, our current index is now at 2. And current index is now at 2, and current 1 is equal to 3. And I'm going to press 3 again. So now our current index is at, what is our current index at? It's at 3, which is the last element. And our current at 2 is going to be 3. And then I'm going to press 4 again. So now our current passcode that we have is 4334, which is not right. And so what happens now is that we use this modulus 4 because current index plus 1 is equal to 4. So 4 modulus 4 is 0. So now our next current index is 0. So we're back at the start. And so now we're going to enter in 4. 4, 4. There we go. 3, 2, 2, 2, 2, 2. Just press 2, 2, 2, 2, 2. There we go. Oh my god, the timing is so annoying. But yeah, so now we'll see that the green LED turned on and the red LED turned off. Again, I highly do suggest you change this timer. The way that you deal with this in normal Arduino programming is something called debouncing, but that's not really something that we have the time to explain. But yeah, so that's kind of an introduction to what an array is. So this is an array, it's just a group of variables that's mixed together that you can access using almost like vector terminology. So you basically just say like whatever your array name is and whatever your element number is. And then you can use for loops, which have the syntax of for, the initial statement, which is going to happen first, a conditional, which has to be true for the loop to continue, and then an after, so what happens after that happens. And so if this is, and then we run our code on the inside. So yeah, if this conditional is passed, we run the code on the inside. If the conditional isn't passed, then we go out of the loop, or we go outside of the loop. The loop is finished. All right. Cool. I hope this was helpful to people. Thank you for listening in. Again, if you have any questions, you can check on the Discord, and we will have basic and challenge problems for this. So yeah, catch you all later. Thank you for tuning in.